All right, guys, this is question number 8 from your practice problems, and I figure I probably need to go over it a little bit because it's a little bit interesting, and we've got to do some tension problems there. All right, so our first little thing here, it says that Zorba is born in London, England, and was measured to be 155 kilograms. So our mass is equal to 155 kilograms. And that means that if we find the force, the weight of gravity, that's going to be 155 kilograms times 9.8 meters per second squared, which is 1,519 newtons. So if we've got 1,519 newtons. What we end up needing to do is drawing our picture. So this is the only force that we have. The other information that we have is in here. We have the harness suspended from the ceiling by two cables that are at right angles to each other. So our two cables are at right angles to each other, which means we have two angles. We have theta 1 and we have theta 2. And so theta 1 and theta 2 and theta 1 and theta 2, if they're at right angles, that means that they both add up to be 90. And so the theta 2, we can say, is equal to 90 minus theta 1. And I'll show you that in our problem here. So we've got theta 1 and 90 minus theta 1 as our second angle. And we know that the tension in one cable is twice as large as the tension in the other cable. So our force of tension in cable 1 is equal to 2 of the force of tension in cable 2. So that's our force of tensions there. So we're gonna have to draw our picture. So I've gone ahead and I've drawn our picture, and we've got our horizontal roof, our ceiling. We've got our mastiff right here. This is Zorba, and Zorba is sitting here. He's hanging from two wires that are making a 90-degree angle. All right, and so if we were to divide this up, this angle right here, if we divide that angle into two halves, we've got theta 2 and we've got theta 1. And so we know that theta 1 is over here, and theta 2 is actually 90 minus theta 1. And that makes sense. We got 90 total, so 90 minus theta 1 is going to give us theta 2. And so that is our two angles. And so we can actually then divide and see what else is going on. Now we know that there's no motion horizontally, so our force in the y direction, or in the x direction, is going to be 0. So this is our force of tension 1, and this is our force of tension 2, and this is our force in the x direction of 2, and this is our force in the x direction of 1, and we've got our force in the y directions now, and our force in the y directions are there and there. And now I know this isn't quite to scale, but it does end up working for us. So we've got our F in the y of 1 and F in the y of 2. And so what do we know about this? What do we know? We know that Ft1 is equal to 2 Ft2s. So we've got that our F in the y plus our F in the y1 plus our F y2 is equal to 1519 newtons. So we can say that Fy1 plus Fy2 minus 1519 is equal to 0. So we know that that is our neutral. We have no motion there. We know that Fx1 minus Fx2 is equal to 0. And we know that, let's see, we know that our Ft1 is equal to 2 of the force of tension of number 2. So Ft1 is equal to 2 Ft2. So what do we want to do now? Now we need to figure out what theta 1 and theta 2 are. And the way we do that is we find out how we use theta 1 and theta 2. And I'm going to pick a different color at this point. And so what do we know about our two things? All right, we do know that these two angles are going to be similar. Right, or those two angles are going to be similar to what we've got up here, because this is 90 degrees presumably. So this is our theta 1, this is our theta 2, and so we can look here and we can say, all right, so theta 1, we've got our vertical component, the y, we've got our horizontal component, and it depends on whether you want to use cosine or sine. So if we're going to use cosine, let's go ahead and use cosine. So we know that our cosine is of our x direction. This x direction, our cosine is going to be our hypotenuse times cosine. So we know that in our x direction we use cosine. So that means that our Ft1 times cosine of theta 1 is equal to our f in our x direction. And so we can actually use that to set this up. And so we know that our fx1 minus our fx2 is equal to 0. So let's find what fx2 is. So our ft2 times the cosine of theta 2 is equal to ft2. Or fx2. And so if we're subtracting those two, we can just plug this in. We'll go ahead and substitute our ft1 here, because our ft1 is actually 2 ft2s. So let's plug this and this in right over here, but we'll use these values instead. So we've got our 2 ft2 times cosine of theta 1 minus our ft2 times cosine of theta 2 equal to 0. So now we can distribute out, we can pull out the ft2's. So this ends up being an ft2 times 2 cosine of theta 1 minus cosine of theta 2 equal to 0. All right, so now that we know what this is doing, now that we know that we have this, and this is still true, we still have this ft2 times 2 cosine theta 1 minus cosine theta 2 equal to 0, let's actually isolate for these guys, because we want to figure out what our thetas are. And so the easiest way to do that is going to be to divide both sides by ft2. And if we divide both sides by ft2, we've gotten rid of ft2. We don't know what ft2 is, but we're looking for it eventually. But we can cancel that out. And so this actually just stays 0, because 0 divided by anything is going to be 0. And so we have that 2 cosine of theta 1 minus cosine theta 2 is equal to 0. Now let's isolate for these two. So the way we do that is we add cosine theta 2 to both sides. So we get 2 cosine theta 1 is equal to cosine of theta 2. Because we know what our cosine was earlier, because we know where our theta 1 and theta 2 are going to be related, we can actually plug in our other value for theta 2. So this is cosine of 90 minus theta 1. And so if that's cosine 90 minus theta 1, we know that cosine of 90 minus theta 1 is going to be equal to the sine of theta 1. The sine of theta 1. And because the cosine of theta plus the sine of theta, especially of a 90, for a 90 degree angle, they add up to 90. And so they add up to 1, sorry. So our cosine and sine, we know that sine of theta 1 is equal to cosine of theta 2. is now what we know. And so we've got 2 cosine theta 1 equal to sine of theta 1. And so that means we have 2 cosine theta 1 equal to sine of theta 1. If we want to isolate then for theta 1, we can divide both sides by cosine. And so sine over cosine is our tangent. So we have that 2 is equal to the tangent of theta 1. And that means if we take the inverse tangent of 2, we end up with our tangent being 63 degrees. Our theta 1 is 63 degrees, which means theta 2 is 27 degrees, because theta 2 plus theta 1 equals 90 degrees. All right, so this is our first big step, and now it's just a simple problem of solving for our ft2. So if we plug that in, we know that ft2 is equal to our, or rather, sorry, let me scroll back up. We know that our Fy and our Fy2 are both equal to 1519, or they add up to equal to 1519. What we can actually do is we can plug this in another place. And so what we're going to do, I'm going to use a different color at this point. I'm going to use, let's use black. All right, so what we want to do is we want to plug in our Fy1 plus our Fy2 minus our 1519. We can actually set those equal now. And so we can set these up and solve for our fy's. And our fy's we're going to solve by taking our ft's and we're going to plug those in. So we say that fy is going to be the sine of theta times the times that hypotenuse. So we've got ft1 times the sine of theta 1 plus ft2 times the sine of theta 2, both equal to 1519 newtons. We can plug in our thetas, so we've got, and we can change our ft1 to be 2ft2. So we have 2ft2 sine theta 1 plus ft2 times sine of theta 2 equal to 1519. And now we can plug in those numbers. We can plug in our sine theta 1 and sine theta 2, or we can go ahead and simplify our ft2's out. So ft2 is equal to 2 times the sine of theta 1, which was 67. Is that right? Was it 63? It was 63. Sorry. 2 times sine of 63 minus the sine of 27 equal to 1519. Add a little bit more room down here. All right, so equals 1519 newtons. And now we can plug that in and solve for ft2. So ft2 is going to be equal to 1519 newtons divided by 2 sine 63 minus sine 27. And if we plug that in, then ft2, I'm going to move it down here. Let's see, ft2 is equal to 1519 newtons divided by 2 sine 63 minus sine 67. That should be a plus sign, not a minus. Sorry. This is a plus sine 67, and we end up with ft2 equal to 679 newtons. So if T2 is 679 and F1 is twice that, so F of T1 is going to be twice 679, and twice of 679 is 1360 with 3 sig figs. And there are the two tensions